Okay, so now let us see some bits of the important notes and then some kinetic energy, and then we see examples. Remember from our previous lesson, we saw that the initial momentum is equal to the final momentum there. So meaning the momentum before impact is equal to the momentum after the impact. In any collision, momentum is conserved, so you can never lose it. And momentum in a vector quantity, momentum is a vector quantity, and in elastic collision, elastic means when the bodies collide, they separate. That's what we call elastic. Inelastic, that's when the bodies collide, they stick. So that's what we call the elastic, and they are inelastic. So elastic collision, when they collide and separate, both momentum and electric energy is conserved. Remember, our kinetic energy is equal to I have mass times the velocity, as you see there. Loss in kinetic energy is equal to the kinetic energy before collision minus the kinetic energy after collision, as you see here. This was kinetic energy of the massive body, the second body, but the half was common and traced it out there. Okay, so after understanding those things, now let us come to the questions or some examples. What do we expect? This is what we expect. A body of mass 2 kilograms moving with velocity. We really have to summarize the equation. So, a body of mass 2 kilograms, so we have m1 equal to 2, moving with velocity, so initial velocity here is equal to 4. Collides with another body of mass, so another body, we have m2, new mass 3, moving with the velocity of 5. So v, our u2 here is going to be 5. Of course, these are meters per second. If after collision, the 2 kilogram mass, now this one moves with the velocity of 2 meters per second. So this one now, the final velocity is 2. These were kilograms, these are meters per second. Meters per second. If after collision, the 2 kilogram mass moves with the velocity 2 meters per second, find the new velocity of the 3 kilogram mass. So they want us to get our V2, which is unknown. So from the principle of observational momentum, our m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. This shows that after collision, the bodies, this was elastic collision, the bodies separated. So that's why we have two different velocities. So meaning here, our m1 is here, we put 2 into 4, then plus we have 3 into 5 equaling 2. Now our m1, 2 into the new velocity, which is 2, then plus this mass 3 with the v2 we are looking for. So this is 8. This is going to be 8 plus 15, that's 23. Here we have 23 equaling 4 plus 3v squared. So after that, when I bring this aside, I get 19 equaling 3v squared. And so from there, start buying the velocity for the second body. It's going to be 19 over 3 meters per second. So that is the new velocity at which this body was moving the 3 kilogram mass. As simple as that. Once you know the formula, the rest are going to be very, very easy. So from there, now we come to this question here. A particle of mass we summarize really as we summarize. Okay, a particle of mass 2 kilograms. Okay, so they are giving us m1 2 kilograms. Okay, let me put the units. Moving with a velocity, so our u1 is 10 meters per second. Collides with a body collides with a resting body of mass. So this body is resting, but its mass 2 is 7 kilograms, but it's resting, meaning initial velocity is 0, as simple as that. After the impact, that means after the collision, the two bodies move with the same velocity but in opposite directions. So meaning that the new velocity for this one is going to be the same. Now meaning the final velocity for this, because they are opposite direction, you can indicate whether this is negative or this is negative, any you take. But they should be, after collision, those two bodies are moving with the velocity but opposite direction. So if this one is, the velocity is the same but opposite in direction. So whether this is V, this one is going to be negative V. Or if this is V, then this one becomes negative V. As simple as that. Once you know that, the rest are very easy. So this one is going to be negative V, the same velocity, but directions are different. Okay, find the new velocity of the two bodies. Okay, so you know that our M1, U1 plus M2, U2 will be equal to 2. Now, because the velocity, okay, anyway, M1, V1 plus M2, V2. So you have M1 here is 2 into 10 plus 7 into 0 equaling 2, because this was at rest, equaling to M1, 2 into V, then plus M2, which is 7 into negative 7, as simple as that. So this will be 20 plus 0, this will be 20, equaling to 2V minus 7V. And see that here we have 10. Okay, this is 20, equaling to this V, which is negative 5V. I mean that our V from here, it's going to be, this V here is going to be negative 4 meters per second. So therefore, because our V is positive, so the velocity, this one shows that we are moving in different velocities. So therefore, the new velocity is equaling to 4 meters per second, as simple as that. So now the next, they are asking us to get the kinetic energy. So meaning we get the kinetic energy, so this was part A. Then in part B, they want us to get the kinetic energy. So we get the kinetic energy before collision. Okay, so let me use this part. Okay, KE before collision, we get this and this. So KE before collision, so KE before collision, we said it's going to be a half into this one, M1 u squared 1 plus M2 u squared 2. But you know that this is 0, so meaning our energy here is going to be a half into our M1, which is 2, times 100 after squaring this 10 here. Okay, people can want to say times M into 0 squared. Okay. Plus 7 into 0 squared. And so from there, I said we are going to have 100 joules, because that is energy. So now, KE after collision, KE after collision is going to be now, we shall get a half into M1 V1 plus M2 V2. Remember, this is the same, but V1 is equal to V2 equaling to that velocity V. So now from here, our KE is going to be a half into M1, which is 2 plus the mass for the second body is 7 into V squared. 4 the whole square. And this is going to be 9. This is 9. This This is 9, 16 squared, divided by that's 8. 9 times 8, and here we get 72 joules. So now, therefore, our loss in KE is going to be the one before, then minus 72, and this will give us 28 joules, and then becomes our answer. So, basically, that's what we had to do for that question. So that's it, members. I wish you well.